Hello and welcome to MJ School of Mining Geology Private Tutoring YouTube channel. Please don't forget to subscribe, like and ring the bell for more videos like this. In today's lesson we are going to learn more about tectosilicates. The tectosilicates in mineralogy are divided mainly into two groups, felspars and quartz. These silicates have a structure wherein all of the four oxygens of CO4-4 tetrahedra are shared with other tetrahedra. The ratios of C to O are thus 1 to 2. Since the CO bonds are strong covalent bonds and since the structure is interlocking, the tectosilicate minerals tend to have a high hardness. This hardness makes them resistant to chemical weathering, which is why quartz is mostly widely available in sedimentary rocks. Quartz is hexagonal and commonly occurs as crystals ranging in size forms microscopic to crystals weighing several tons. Where it crystallizes unhindered by other crystals, such as in cavities in rock or in a liquid containing few other crystals. It shows well-developed hexagonal prisms and sometimes shows apparent hexagonal pyramids or dipyramids. When it crystallizes in an environment where growth is inhibited by the surroundings, it rarely shows crystal faces. It is also found as microcrystalline masses, such as in the rock chart, and as fibrous masses, such as in chalcedony. All quartz can be identified physically by conchoidal fractures. Quartz has the highest melting point, but the SiO2 content, which increases towards the bottom of the Bowen's reaction series, makes this quartz to melt first. This is why felsic materials are the first to enter the melt during partial melting. As visible crystals, quartz is one of the more common rock-forming minerals. It occurs in siliceous igneous rocks such as volcanic rhyolite and plutonic granitic rocks. It is common in metamorphic rocks at all grades of metamorphism and is the chief constituent of sand. Because it is highly resistant to chemical weathering, it is found in a wide variety of sedimentary rocks. Several varieties of quartz can be found, but these are usually only distinguishable in hand specimen. Rock crystal, clear quartz and distinct crystals usually found growing in open cavities in rock. This is a naturally occurring crystal and it is clear because it has no impurities. Amethyst, violet-colored quartz, with the color resulting from trace amounts of Fe in the crystal. Rose quartz, a pink-colored variety that usually does not show crystal faces, the color resulting from trace amounts of T+4. Smoky quartz, a dark-colored variety that may be almost black, usually forming well-formed crystals. The color appears to result from trace amounts of Al+3 in the structure. Citron, Thysis, a yellow-colored variety. Milky quartz, a white-colored variety with the color being due to fluid inclusions. Milky quartz is common in hydrothermal veins and pegmatites. Quartz is uniaxial positive with a low relief and low birefringence, thus exhibiting only one-order gray to one-order white interference colors. In thin sections it is almost always colorless when viewed without the analyzer inserted. One of its most distinguishing properties in thin sections is that it usually has a smooth, almost polished, colorless-like surface texture. Quartz is easily distinguished from the feldspars by the biaxial nature of feldspars, and from nepheline, which is uniaxial negative. Apatite has similar birefringence to quartz, but is uniaxial negative and has a very high relief. Although color is not reliable for the physical identification of minerals, for optical identification color is very useful and reliable. Most minerals are colorless under PPL, but some minerals are intensely colored. Generally, dark-colored minerals in hand specimen are colored in PPL. Light-colored minerals are colorless.